Okay, welcome back, physics fans. Here we have question number 24, and it's part of the advanced physics in one-dimensional kinematics that I'm doing. I call it advanced because it takes more than one step to get the final answer. So when it takes multiple steps, you have to kind of think about why you have to take multiple steps and what information you have to take from step to step to get the answer, and that's important. So here we go. A cyclist is riding at a constant speed of 5 meters per second when she sees a flash of lightning. Wanting to get home quickly, she accelerates at 1 meter per second squared for 4 seconds, rides at a constant speed for 3 seconds, and then takes another 12 seconds to slow down uniformly to rest. What is the total distance traveled after seeing the lightning flash? So the lightning flash hits, and this is the beginning. So her speed at this point is 5 meters per second when it starts. And she accelerates at 1 meter per second squared. And the time that she accelerates is for 4 seconds. So we have our three information. What can we get from here? Well, we're going to ask for the total distance for the whole trip. So we'll definitely need to calculate the distance here. We will also need to calculate the velocity because that is the constant speed that she's going to be moving at. So in phase 2, this is constant speed. But she's going to be going up in speed. She's going to be ramping up in speed, and we need to know what that speed is because it's not 5. Okay, so we will need to calculate the VF as well. So I'm going to calculate the D first. D with these three is without the VF is going to be D equals VIT plus 1/2 AT squared. D is equal to VI, which is 5, times T, which is 4. And that's going to be 20, and that's if she didn't accelerate, she would have traveled 20, speed times time. But because she accelerated, she went a further distance. So 4 squared is 8 times 1/2 is, 16 times 1/2 is 8. Sorry, I was working too fast in my head. Here we go. 20 plus the 8. So she travels a distance of 28 meters. We now want to also solve for VF. VF without D is just going to be VI plus AT. It's going to be the definition of acceleration formula. So VI is 5 plus 1 times 4, and that's just going to be 9. 9 meters per second. So that is the speed that she ends up at the beginning, and that's the constant speed section. So the speed in this constant speed is 9 meters per second. We bring it up. And she rides at the constant speed for 3 seconds. So time is 3 seconds, and the distance at a constant speed is velocity times time, and that velocity is 9, and the time is 3. So distance is going to be equal to 27 meters. So we have two of the distances so far. That distance and that distance. Now she's going to be moving into the third phase. And her speed going into that third phase, and this was the first, constant speed in the third phase. Third phase, the speed going into it is 9. So her initial speed is now 9 meters per second. And going to take 12 seconds to slow down to rest. So her final speed is 0, and the time taken here is 12 seconds. Yay! We have 3 things. We need those 3 things to calculate the stopping distance is what we were trying to figure out. So distance is, well, the only formula without a in it, even though she is accelerating here, but we're not given the acceleration or the rate of acceleration. This one. And in this brackets, that's the average speed, but VI plus VF divided by 2 times the time. And we get VI is 9 plus 0 all over 2 times the time of 12. So 2 and the denominator 12 is in the numerator. So that could be 6. 6 times 9 is 54. D is equal to 54 meters. That's her stopping distance at that point. So that's our third distance. So the total, bring it down here, the total will be 28 plus 27 plus 54. And that means the D total is going to be equal to 109 meters. So what makes it a challenging question? Not the individual steps, because these three givens calculate that, these three givens calculate that. Knowing to do that, yeah, that's what's difficult. Knowing what do you calculate? So it takes a bit of drawing it out and knowing that it's asking for distance, so you have to solve for the distance in each one of them so that you can add them up. And seeing it as three separate motions takes a bit of effort, bit of skill. Take a look at it. Anyways, thanks for paying attention and enjoy. Remember to subscribe often. Leave your comments down below.